Hi and greetings everyone. Our topic is determination of sulfur dioxide in orange juice using FTIR method. Our group members consist of Adlin Hanani, Nurul Azizatul Adawiyah, Muhammad Rifki Yazdan, and the last one, Rabiatul Adawiyah.
Okay, so what is sulfur dioxide? Sulfur dioxide is a chemical compound with the formula SO2, is also known as a sulfur oxide. Sulfur dioxide and sulfate is used widely in food industry as preservative that control microorganisms and act as antioxidant. As an example, wine, jam, dry fruit and fruit juice. So for this experiment, we use FTIR method to determine sulfur dioxide in fruit juice. This method was used because to generate an accurate and dependable analytical method for assessing the amount of sulfur dioxide present in sample. For our aim is to establish a reliable and accurate analytical method for quantifying the concentration of sulfur dioxide in fruit juice sample. Next is our objective. So our objective to optimize the signal to noise ratio, resolution and wavelength range of the FTIR measurement for the purpose to determine sulfur dioxide in fruit juice sample with sensitivity and accuracy.
Literature review. Passion fruit is a nutrition tropical food and it is a fantastic wellspring of dietary fiber, nutrient, vitamin C and vitamin A and contain fair amount of sodium, magnesium, sulfur and chlorides. FTIR spectrophotometer was used to identify chemical constituents in two types of passion fruits. The results show following permissible limits of the preservative as sulfur dioxide 350 ppm or as a benzoic acid 600 ppm. Next, the FTIR spectra of two white wing examined show absorption band at various frequency white wing added SO2 at 40 ppm and we use a pinene, which is a fragrant monomeric compound derived from fruit aroma compound, and as an alternative for SO2 in white wine fermentation. Last, sulfur dioxide or SO2 is the most common additive used in winemaking for many years. This compound is important for wine producer and consumer due to its antiseptics and antioxidant properties. Some other authors review the side effect of SO2 used in wine, but none of them have comprised the effects.
Okay, I will continue with the methodology of the experiment part. Roughly speaking, we will conduct this FTIR experiment by following the steps in the flowchart on this page. First thing first, we need to clear the surface using a non-abrasive wipe and a few drops of ethanol. After the surface is clean and dry, we can do the experiment with less error. The first step is we need to run the background spectrum without any samples to be specific without fruit juice. Then, 2 drops of sample are placed on the exposed crystal surface using a dropper. Since the sample is in liquid form, no need to clamp the screw. But before that, we need to make sure that the scan setting is right, such as the method parts are ticked only at certain and correct method. The wave numbers are in the range of 4000 to 650 per centimeter. And the important part is the unit of y-axis is transmittance. Following that, we can run the sample by pressing the sample measurement button on the screen. After we get the result as data, we need to remove the sample using a non-abrasive wipe and a bit of ethanol and make sure it is clean and dry. Afterwards, we can proceed with the experiment conducted with discussion of the results obtained like the spectrum, functional groups and the library part. For details of the methodology, you can scan the QR below.
Alright, here comes the result. As you can see here, there are FTIR spectrum, which we intend to find a specific preservative, which is sulfur dioxide. After FTIR analysis has been conducted, we can extract the spectrum using the software downloaded in our laboratory computer. As you can see here, we can find the functional group analysis of our sample, and here are the list of our matching functional groups, which is unsaturated hydrocarbon select. So yeah, alright, let's go to our main objective, which is to find sulfur dioxide. And before that, you can see here we have comparison of our sample and comparison of library from the computer. As you can see here, the most matching is Sprite and our sample. The higher the quality, the better the matching spectrum as our sample. So, and here's come the surprise, where we found that they don't use sulfur dioxide as their preservative, and we found sodium sulfate, which means they use it as a preservative instead of sulfur dioxide. Sodium sulfate is also widely used as a preservative. So yeah, not only sodium sulfate, but we can use not only sulfur dioxide, we can use sodium sulfate as preservative. That's all.
For our conclusion, from this experiment, we can conclude that in our sample, there is no sulfur dioxide detected, but there are sodium sulfate that had been used by the production as a preservative. So this study is significant because it can provide a dependable and effective analytical tool for detecting the sulfur dioxide in fruit juice. However, there are limitations to consider, such as sensitivity. Lastly, for recommendation for future work on our experiment is method optimization. The sensitivity and precision of sulfur dioxide detection in fruit juice sample, further adjust the FTIR method parameters such as wavelength ratio, wavelength range, resolution, and sampling strategies.
That's all from us. Thank you.